Abdul, how's it going, man? I appreciate you for joining me here. Welcome in, number first one of the day. How you doing? All right. Sweet. Let's roll. All right. Hello, everybody. Thanks so much for coming in today. Welcome back to the stream. Hope you're having a wonderful day so far. Truly, truly. Welcome back in. It's always fun to be here. All right. Let's go ahead and get the... sorry I was gone yesterday. I just took a little, took a day break. Everybody deserves a day some days. So yes, we did lose our streak, but that is okay. You know, never fear, never fret. My hair is really crazy with these, it's getting long here. Never fear though, it's okay. We are gonna start back up here and keep on pushing. Everybody deserves a day. Especially after we released our project. So we're super happy that we're able to release and launch up our SpectroSim, right? So we have SpectroSim.com, right, which has the ability for you to go and run this whole thing on the web. So currently, though, there has a spin down time with the API. So we might need to write some stuff on here to make it, to let them know. Right, it's still spinning. Come on. That spin down time is brutal. So render.com, where we're hosting our server, our backend, has a spin down time that if you haven't used it in a while, it'll take a while to load. So this is embarrassing. Oh gosh. Wonder if there's anywhere else we can host a backend that doesn't have this. See, there it goes. Finally got the response here. Right. So then you can generate. So now we can do this pretty quickly. We can start searching up stuff. Let's say like... There you go. Start searching up. Let's search up like... Like Kumarin, let's search up like let's just say gold, right? No UV vis data for gold. Pretty cool. Hey Matt, oh sorry. Tesseract, hey Max, hey Eduardo, welcome back in. Hey Douglas, welcome back in on Twitch. Man, my hair is really crazy. I don't like this little curly cue. Oh gosh, we'll have to pin it back here. Tuck it away. Sorry, looking like a bum over here. My bad, guys. Okay, I appreciate you guys for being here. Jeez, I gotta get a haircut. This is ridiculous. Okay, welcome back in, guys. Okay, so, oh, the chat's not working. Where's the chat? What's going on with chat? What's going on with chat? Where's my chat? Oh, hold on, guys. Oh, that's why it got quit. Why did it quit? There we go. There we go. We're back. Sorry, guys. Got chat going. Great Clips is $20. Hey, we got stocks to buy, Max. $20. We got stocks to buy. $20. I'm cheapskate for real. My bad. Hey, Kamal, how's it going? Welcome in. All right, you guys. So we already completed this project, SpectroSim, obviously the at least first iteration of it to do the general purposes of this project, of what it needs to do. So,
This is Pierre from Iloilo City. Hello.
how's it going, Pierre? I appreciate you for coming in. Yeah, so we've already finished this project. This was our most recent project. We are going to add this to our portfolio website. I do need to fix a bug on mobile. You're actually not able to click this drop-down menu, so I do need to fix that bug. But everything else works. I do also need to fix on mobile view, right? On mobile view, you can't hover, so this feature doesn't actually happen. So I just need to make it just look like this no matter what when on mobile. So there are some bugs that we need to fix with the overall project. So that we'll keep that in mind, but that's not really the purpose of today. Today we are jumping back in. It's good to be back. So yesterday I was gone. I did have a day off. not really. I did go to work, but took the evening off from coding. I did.
What are you making specifically?
Um, so hold up. So what I did is I went to a concert yesterday. It was a lot of fun. It was a good time to get some chill, good vibes with my girlfriend and hang out and just not really worry about coding yesterday. Even though I did miss the stream, it felt weird not programming every day like I have been for the past while. So yeah. So I appreciate you guys for being here. Welcome back in today. It's great to get back into the flow of things and back onto the stream. So we left off on 2 days ago launching our SpectroSim project, so you guys can access this on spectrosim.com. We have we're going to make some more simulators, right? Just the ability to make more simulators. So this is the AbsorbSim simulator, where you can search compounds and generate their absorption simulation via their absorption spectroscopy, which is really neat. And using this live plot, and then you can also download plots, which is pretty cool as well. So super happy with that. Hey, how's it going, my friend? How's it going? And welcome back in. Let me know what you guys have been working on, what you guys' goals are. If you guys are new to programming or been programming for a while, let me know more about you guys. I love hanging out and meeting with you guys and talking with you. If you're not in my Discord, link down below. You can access to all of my learning resources. I've been programming for 1 year and teaching myself from scratch, and we've come a long way, pretty much gaining some pretty good intermediate fluency in Python and starting to transition it into full stack web development and projects and kind of more product developments, systems stuff along those lines. So it's really awesome. Okay, let's kind of shift focus here. I want to today. I don't really want to work on SpectroSim today. I want to put a little bit of time between us because we've been really grinding away on this project for the time being. Even though I do have those bugs I need to fix regarding the mobile view for the hover effects, right? I do need to fix those. Hey, how's it going, Script Servant? Welcome back in, dude.
Tesseract says, if you have a need for detecting classifying, I just released a new binary classifier.
All right, let's keep rolling here. So I think today... All right, so I think today I would like to... we're going to, I think, solve a LeetCode problem today. Uh-oh. Oh, whoops, my bad. We're going to solve a LeetCode problem today, so wish me luck on that. So I know you guys have been waiting for that for a while. What else do we want to do today? Should we do some more calculus? Or should we... I don't really know where to go from here. So we've been talking in chat about the Wackathon project, especially in the Discord. I've come up with an idea of a project I want to build as a community with everybody. So I appreciate your guys' feedback regarding that in the Discord Wackathon section. So if you guys are wanting to participate in a community-based project where we build something like live all together, rather than having me build kind of a project and then release it as open source, we'll kind of start from scratch, assigning out various assignments and tasks for people to do and groupings. And so I'm going to have it opening up registration, like just via Google form. So if you'd like to participate in that, you have to be active and be willing to code like almost on a daily basis. So if that's something you're looking for, I'm definitely interested in that. We could definitely be working in a group of on Discord calls, and I could be streaming the entire thing. So it could be very, very cool. And I have the idea in the Discord if you're interested in that. Oh, there goes the kitty. The dog's chasing the kitty. No, don't chase the kitty. Come on, leave her alone. Okay, so what do we want to do today? That's the question. I've been building this project for so long that I've lost track of what I want to do. Right? I've been building this for so long. I kind of don't know what else to do now. Do we go back to reading our books like Fluent Python, DSA in Python, and Python Machine Learning, or do we keep doing our calculus course? I don't really know. I'm kind of at a crossroads here. What are you guys interested in seeing? Okay. For the meantime, let's go ahead and at least, I guess, open up a leak code problem. Oh, God. Yeah, this is gonna suck. Hopefully we don't get a bad one. We go by random here. Let's go difficulty, easy. Alright, here we go. Let's find one. Which one sounds fun? Biggest single number? Oh, this is a pandas problem. Let's solve the leak code daily. Oh, it's an easy? Okay, let's try this one. That's a good idea. Okay, let's try to solve the leak code daily. Here we go! Alright, you guys, let's load up the leak code daily. Remember, no spoilers in chat, please. I like to try to solve these, independently, but also, with you guys as well. Like we can, bounce ideas off each other, but please refrain from just dropping, writing code and just dropping things. They just give things away. We're trying to learn here and grow. So, anyways, let's get into today's leak code daily. So this is 3423. Maximum difference between adjacent elements in a circular array. Oh gosh, long title. Uh-oh, what are we doing here? What are we doing here? Given a circular array, so this array is circular, so that I'm guessing that just means that when we finish the end points to the start, or the head. The tail points to the head. The first and last elements are adjacent. Okay, so input 1, 2, and 4. We output 3. Maximum difference between adjacent elements in a circular array. Because nums in a circular array, because nums is circular, nums 0 and 2 are adjacent. They have the maximum absolute difference. Output is 5 here. Explanation. The adjacent elements nums 0 and nums 1 have the maximum absolute difference. Okay. So the thing is we don't want to run this in O of n squared by doing the mathematical check here across every value with a nested loop across every inner value and then moving that outer loop over 1. So instead, okay, so if it's a two-pointer approach, interesting. So I haven't done a leak code problem in a little bit, so I gotta get the brain focused on this one. Gotta get the brain thinking about this. So nums is circular. So we just need to find, out of this, we just need to find the maximum between, the absolute maximum difference between any two numbers in the array that are adjacent. Oh, okay. And the ends can be adjacent, so we have to check those. Okay, got you. So that's what so adjacent elements. So you can only compare an element that's next to it or that is on the end, either on the two ends. Oh, this is interesting. So if you have 2 pointers, and you start one at the start and one at the end, well, then you can do that check there. So let me open up a whiteboard. Let's think about this one. So let's say you have an array of numbers here of like 2, 3, 7, 1, and 4, right? Let's say we start our left pointer here and our right pointer here. Okay? This is a valid check that we can do. If it's adjacent, we can do this check. Okay, so is this a sliding window thing? We have a fixed window of a length of 3 that we check on the middle value as we shift this window down. And we take the difference between here and here, determine the maximum between them, and evaluate if that is max. Shift the 3-piece window here. Right, shift here, evaluate on this number, but then just evaluate on the ends as well at the very end of the loop. Interesting, right? Because that's how adjacent elements can have one of 2 options, A or B here. So you have to evaluate across a triplet almost, right? And then you just shift the triplet down. Now what happens though on the first number here? Oh, well your triplet, oh interesting, because if you have, with the circular array and how it is, right? With the circular array, your triplet can be this, right? Interesting. So you do start. So if you start, okay, so then we have a leader and a lagger, right? So if you have your lead, and then you have the lag on -1. Ah, okay. Okay, interesting. So let's think. Let's pull this off to the side here and bring our whiteboard over here. No, it's gonna be annoying. Oh, come on. Come on. Okay, it's not gonna work. Okay, so then, that's interesting. So if we have our lag be -1 and our lead be 0, and then we just and then we have, okay. Lag equals to 0, or sorry, -1. Okay, and then we say so then what happens though, let's think about it. What happens though if we get to, so our lag is going to be -1 here, but if we increase it by 1, it becomes 0 up by 1 all the way up until we get to n. Well, what do we want to stop the check on? When 4, the last value, is our middle value. right, is in the middle position. 4 is when that's when we want to stop, because our lead will then extend. If lead becomes n, the length, then reset lead back to 0. Because lag will be here at 1, middle will be here, and lead will then be shifted back to 0 to evaluate the adjacent values on the 4. But if we do, that's interesting. So hold on, let's see here. But if we do, if this is our window, we do this evaluation, we shift forward. So I'm thinking, like, could we like cache already done values first, like adjacent values, so that if we see the same mathematical math happening, we don't need to do it? Like, can we map already done I mean, we're kind of getting into the weeds here, right? But it's just a thought of, like, if we've already done a 2 and a 3 and there's a 2 and a 3 elsewhere adjacent, right? If this is a 2 over here instead of a 7, then we don't need to evaluate, both. Okay. So then how do we manage how do we get to our stopping point? When our lag is here, our mid is here, and then our lead is here, right? Now I know we can brute force it. I don't really want to worry about that. We're going for the hard approach. Okay, so then if we then shift, if our lead becomes n, we just need to then rotate. We just need to reset lead back, right? So if we say lead, now how do I want to set it up though? Like, how can I do it with a loop? Right, how can I do it with a loop do I need variables for all three, or how can I just do it with so if I say n is equal to the length, we'll just keep this of nums, right? We'll keep reference of the length. And we say for lag is -1. So n in this case, or with this loop here, I is going to be the mid. Like for mid in range of n, right? Then how can we for mid in the range of n? This will go up 0, 1, up to index 4 for mid, right? And then, but if mid equals 4, I need to set my lead if mid equals to n less than 1, then we're going to set lead equal to mid, or lead equal to 0. So what if I say the lag is equal to mid -1? off the bat. I think I can do that. On every iteration. So if mid is equal to n minus 1, we're going to set the lead to the front to represent that circular array. Else, right, we're going to set lead to just mid plus 1. Okay, so now we have our variable set where we will evaluate like adjacent numbers. Okay. So then can I say okay, now we have this established. Now I'll move one step at a time and do the evaluation. So we'll say left val is equal to the absolute value of two adjacent numbers next to each other. Okay, so it'd be nums at index of lag less nums index of mid, right? And then we'll copy this down. This is going to be right value is absolute value of mid less the absolute value of the lead. And then we say max val, max between is equal to the max of left. I mean, we could just call max of this, right? So let's just break this down even further. We'll just say max of absolute value, comma, absolute value here, right? So then this gives us to val equals here, and then we'll save max diff equals to, is it, we want to say none at first, potentially, and we say so this is if this only works if you have a array of size 3 or more, right, though? Interesting. So we'll have to say like max diff equals to value. We'll just say if max diff less than value, no, say max diff is equal to the value if max diff is less than value, right? I always like it writing those, so I'm just going to go back the other way. If max diff is less than the value, then we're going to set max diff equal to the value that we found. And then else we're just going to just continue on. Now, if n less than 2, right, return none. And then if n is 2, if n is 2, then we just return the difference between the two values. I mean, I don't know about this code I'm writing. It's pretty sloppy, I think, but I'm just getting the vibe that it's pretty sloppy. And I haven't looked at chat yet, though, so we'll see here. You guys probably roasted me. If n is less than 3, I haven't been writing by lead code in a while, guys. Okay, so if n is less than 3, then we have a value of 2. So we're just going to return absolute value of nums 0 less nums 1. So at the end of this, we're going to return max diff. All right. I wrote a lot there. Let's see if we're even close. Oh, we got an error. Oh shoot, didn't mean to submit, my bad. So we'll say 0. Okay. No way. No way. Dude, no way. Am I that guy? Am I that guy? Hold on, we gotta look at this. Yo, hold on. Am I that guy? Hold on. I haven't looked at chat yet, guys. I haven't looked at chat yet.
I'm the guy. Stop saying you're the guy. We all know that you're not the guy. He's not the guy. I am. And you are? I'm the guy. The real guy.
The real guy.
You're not that guy, pal. Trust me. You're not that guy. Okay? Okay? Are you? Absolutely.
Absolutely. Oh, we love the memes on this channel. Let's go! So there is a faster solution, though. Ah, dang. Oh, no. So is this the one where we cache already done solutions? It might be. Let's get caught up on the chat. My bad, guys. Let's get caught up on the chat here. Let's get some music. Which music we want to listen to? Let's go with the go-to, the OG. All right, let's get caught up on chat. My bad, guys. All right. I'm Mike. Hey Tim, how's it going? This is my first time watching you, but I feel like if you get the syntax and ability to resolve errors and have the ability to break down the problem you're attempting to solve, it is necessary. It's JavaScript, you really can't do Mike, where are the job applications? If we all apply to the same role, surely someone will get it. Okay, so I'm curious to see if we can improve this to cache results that we've already seen, right? Like, can we let's do this. Let's say scene I don't know. It's interesting. I mean, we could say scene and have a map with the keys as the individual, like a tuple. We could create the tuple off of left and right with the lag in the lead off of mid and detect it inside the scene map and just get that value. I mean, but we're doing constant operations here, so it's not like we're doing them on everything, so it does slow us down a little bit over time. But we are doing it linearly. All right, cool. Moving on. That wasn't too bad. Feels good. Median of 2 sorted array. Let's find something here. What do we want to do? Oof. These mediums are take a stab at a medium. Given 2 strings, word 1 and word 2, return the minimum number of operations or convert 1 to word 2. Oh god. Yeah, the following 3 operations permitted on a word. Insert a character, delete a character, replace a character. So word 1 is horse. Word 2 is Ross. So we replace the H with an R. Oh my gosh. No. Uh-oh. Back it up. Back it up. Back it up. Back it up. Oh my gosh. That one looked hard. We're cherry picking, boys. We're just easing back into it. We're easing back into it. All the easy ones I've done. Literally. Come on. How's it going? Welcome back in, dude. Your bet is Thunder and 5 down the drain. Dang, dude. Did you put money on it, Tim? I've done all of these easies. Is it time to start taking a crack at some mediums? Oh gosh. Here's Tim's favorite. given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Oh. Crap. See, when I see stuff like this, like my first impression is like recursion, right? Like to, but honestly, like this is kind of similar to the last kind of one medium that we stopped by. I'm just not entirely sure. Like, I mean, we gotta learn, right? So if you start with a singular parenthesis, right, you just can close it, or you add another, and then you have to close that one. But that's not valid because you have an open parenthesis. But this is for 3 sets of parentheses, pairs of parentheses. So in total you have 2 n parentheses. So I guess you could keep like a variable count, right? And say like how many you have a total of 2 n parentheses. So then could you have like open parentheses, and like if you open one and then remaining to use, right? So then if you place an open parenthesis, that would reduce from remaining but increase open. And if you end that recursive loop with any in the open tracer, then it's an invalid parenthesis combination. It's interesting. Oh, nice. Since 2020. What are you betting, like dollars a day? Jeez. I'm not sure, Andre. We're trying to figure that out here. Right? Okay, so if you push an open parenthesis onto the stack, so let's just walk through a little bit of writing here. So, right, you have a stack of parentheses, right? So let's say you have n is 3, like in the example, right? So I come here, I have a total of 2n, so I have a total of 6. Okay, so if I open a parenthesis, I can either do one of two things. I can close it, or so I can either close it or I can open another parenthesis. And from there, okay, so, and then from there I can either close it or open another parenthesis. Okay. So now, how do I determine? So if I have an open parenthesis as my starter, does this go onto the stack? And then let's say I how can I use this stack? So I have, if I use this parenthesis, I push it onto my stack. parentheses, if I make an open another parenthesis, I push it onto the stack. If I close a parenthesis, I pop off the stack. I pop off the stack. If I have stuff on the stack at the end, then I'm invalid. Right, so if we go through this, we say, okay, I have an open parenthesis, I add that to the stack. I add another open parenthesis, that goes onto the stack. I close a parenthesis, I remove from the stack. I close a parenthesis, I remove from the stack. Okay, this is valid, but I don't have a total of 6, I only have 4. Right, so I have to add 2 more. I open a parenthesis, I add to the stack. I close a parenthesis. I cannot open a parenthesis because that'll leave me on the stack, leave me values on the stack. So I have to close a parenthesis. That's valid. And then that goes away. Right? Okay. Tracking stocks, I'm tracking the lines. Hey Kim Long, thanks so much for the love, man. I appreciate you. How you doing, man? Okay. So our stack is going to be equal to an array here. And we'll say, right, total, or we'll say, if I assign a helper function, given the current stack, or given the current stack, or given I always get confused. So let's just say if I have a so what do I want to pass in here? Right, the number of available items, right, and then the stack of items that's currently there. Okay. So then if I say say total paren paras is equal to 2 times n, right? So then if I pass in total paras and the stack into my helper function. Now if I say on a base case, right, my base case is if right, if total paras is equal to 0, right, we've run out. So then can I, so I'll say valid equals an array here. Oh, this is getting interesting. So if I say if total paras is equal to 0, right? What makes, and so if I've reduced total paras all the way down, right, and stack and not stack, we're going to return, we're going to do we need to pass in stack and Oh god. Pass in stack and oh, but pass in stack and I need to pass in so total pairs, stack, and then I also need to pass in, I'm losing my train of thought here, come on, keep thinking. So then, what if instead of using, no, hold on. Let's do this. Let's say lefts equal opens equals an array of quote unquote parentheses right times n divided by 2, right? And then we'll copy this down, we'll call this closed. We'll say open. I'll say opens, close. Say opened. Open, closed. So we'll set this to here. So now we'll predetermine these. Okay. So now I'll say, now I'll just pass in opened, closed, open and closed. Then I say I need to pass in you have to pass in the string that was formed, right? Valid is equal to right. Okay, so let's think here. So if I set this, I don't know, is it a good practice to set things in the function definition? Or set it outside? Well, if I set it in the function definition, it'll get reset every single time. I don't want to do that. So string is equal to this. Oh, we could just plus them together, right? Well, we need to pass in the string still. But we have to have a blank string defined. So if I say, okay, so if I say string is equal, so what's our base case? If not opened The thing is you can't close parentheses without having one open though. So that's why I was liking the stack approach. So what if I say, this is interesting. So if I have a open and closed, the amount that you have, and then I have stack. The return value of helper. Okay, let's think. So if I am trying to, right, I have to place an open parenthesis first, right? So right off the jump. Generate parentheses. Give an n pair of parentheses, write a function, generate all the combinations of well-formed parentheses. Okay. So if I have a total of n equals 3, I can have 6 total parentheses I can place down. Okay, I have 6 total parentheses I can place down. If I place down an open, I have to place down an open one first. So okay, so I'll say we'll have a function here called place para is equal to, or we'll say def place para. And what do you need to place para? Well, you need the number of parentheses left to place. So this would be total paras. And then you have to place, I have to also keep track of the string that is created along the way. Right? So I'm going to call, so string and total pairs. Okay, so then if I say so the place pair, all it's going to do is if total pairs, right, if it has total pairs, then we're going to do string plus equals one option, and then Okay, so I need to build the string recursively. And then at the end, validate if it's true by checking to see if there's any values, any open parentheses in the stack left over. Or if the length of the stack is if the length of the stack ever becomes, okay, so we'll do this. Oh, come on. Okay, so how can I set this up recursively, right? I need to have a stack is going to be equal to an array, okay? I have total is going to equal to 2 times n. Right? And I say while total I'm going to call no, let's just say this. So let's do this. So place, we'll just say def helper. I'm like walking in circles, you guys, sorry. Def helper, given the current stack and given the total, and then given a string to create, which is an empty string out front. I'm going to place okay, so what does the helper function do? So some base cases. So if not, so okay, we're going to say we have helper here. My cat going crazy in the litter box right now. The max length of the string, if n equals 3, is 6 to n, right? So that's what we're calculating here. So total okay, so then we're going to say if total is equal to 0 and so if we're out of total and stack, if total is equal to 0 and we have stack values, then this is going to be just return none. Return false, maybe. So if total else, if total, so if total is equal to 0 and not stack. And we don't have anything in the stack. We're going to return string. So else, if we ran out and the stack, okay, so now we have values in total. We're going to do string plus equals. I don't want to do string plus equals here. I need to I return a tuple. Right, of right? Do I return a tuple of either option? And or like so I'm going to oh gosh. No, I did not, Brett. Okay, so if we or attempting shrouded, we're attempting here. I'm not trying to back away from it here, we're trying. Okay, so the thing I'm having difficulty with is when do I want to call this helper function? Right, so I have one of two options. So I have a stack and a total, and then I have valid is equal to. So I could check if it's valid. Dang, I'm really struggling. Interesting. Okay, so we have, if n equals, so we have a total of 6, right? On a total of 6 in this first case. If we place down, if stack is empty, so if stack is empty, you have to place down an open parenthesis, right? Because if you have a value in the stack, then that means that you have an open parenthesis that can be closed. But if you don't have anything in the stack, if you place a closed parenthesis, it'll become invalid. Okay, so if not stack, then we're going to do string plus equals to a open parenthesis, right? And we're going to return, so if not stack and total, we're going to reduce total by 1 and place a string, an open string. Right. If stack so if you have something in the stack, you have the option and total, right? Then you have to reduce total by 1, and then we need you can do either or. Well, if the stack's length ever right, ever exceeds half of total, then it's invalid. Man, there's so many things I don't even know what to start with. So if stack and total, then we're going to reduce total, and then we make the string make an open one. So then let's call place para or add para on. We'll add the para of open, and then we'll also add the para of close. We'll call add para of just the open here. Okay, so if you have nothing in the stack, meaning that you're not allowed to place a clothing parenthesis, but you do have values in the total, meaning you need to place a parenthesis, you have to place an opening. If you have values in the stack, meaning that you have opens in the stack, and so then we're going to have to do stack dot append right, stack dot append the parenthesis. So that might have to happen inside of the recursive of add para here, right? So if we define add para here, given a para as a string, right? We say, and we have to pass in though the instance of the stack, right? We need to check the stack on each recursive call. So if we add the stack to the passing and add parent, so this is a list, right? So we'll call add para for this. So then we'll say, and we'll be given a string, which is stir as well, right? So in our add para function, if I say this just adds the para, so this goes string plus equals para, we'll say, hold on, if string equals to an open parenthesis, we're going to call stack.append para. If para is equal to this, append para onto the stack, and then string plus equal para, and then else, and then we're going to return string stack para. Okay, else we're going to say stack we'll say if para equal to a closing parenthesis, we're going to stack dot pop just whatever's off, and then stack.pop, we pop off of the stack, and then string plus equal para, and return in both cases, return this. So in both cases, we're going to return unless you don't put it in. Okay, so then if not stack in total, we reduce total down by 1. So I'm going to say while total, if total, if not stack and total just adds a string onto it. Right. while total, we will reduce total down. We'll reduce total down. Total equals to 0. Okay, so we have add parenthesis, and then we have okay, so think about this, Mike. If I'm trying to add parentheses to check if validity using recursion, right? I need to have a base case. Well, what is my base case? Well, my base case is if I run out of parentheses to place, right? I don't have any more valid parentheses to place. At that point in time, do I have a valid string? Well, I don't want to have to check over the valid string at that point in time through a pass. If I want to keep track of validity as I go, that's why I'm using the stack here to push open parentheses onto the stack and evaluate if there are values in the stack, or a counter basically, rather than a stack, same thing, right? So like we say, I mean, I'm just using a stack here, but we could just increase a count, basically, and right, you know. So then we'll say so if we work all the way through the recursion and then we return if we return, and as we return back, we push elements onto a stack to check validity on the way back, or can we just recursively call down to the end and then be done from there? So I'm trying to figure out here. Right, so if I place down a parenthesis, I can do one of two things. I can either close it, or I can place another opening. But if I place another opening and I run out of values, that's not valid. This one is valid. So if I'm adding parentheses, returning a string, stack, and a array, I'm saying while total, if not stack and not total, do I push the initial parenthesis on to start? Like, I think I have to. Or do I go do stack dot append the starting parenthesis and then reduce total by 1 before I enter the loop just to get it started? So while total, if not stack and I have a total, then I'll reduce total down, add this to the stack, so add para given the string is going to be initially blank, right? So then if I say add para given string, the current stack, and this parenthesis open, what happens if I take this, put it here, and then do it for this as well, here. So total will be reduced. This gets returned. We then put this as string stack. I don't need a return parenthesis. Let's return string and stack. So that we can use them in the next go round. But I'm not appending to valid here within my recursive call. Oh shoot. I think we need to start over here. Oh, it's alright. It's alright, we're learning. This is fun. We're convincing ourselves this is fun. Nice, Steve. Just started yesterday, dude. Nice, man. You're kind of in the footsteps of me. I started a year ago. And I've been teaching myself. Join my Discord down below, Steve. Appreciate you for joining here, man. Okay, so let's see. I don't want to give up on it and come back to it, but I think we might have to do some more research on some of these topics. So, if we place a parenthesis, Mr. Steve. Okay, so interesting. Let's think. So if I place, let's go back to the whiteboard. Where you at? Okay. So if I take on my recursion, I can either open a parenthesis or close a parenthesis. Well, right off the bat, this is going to be invalid. So why not just place the open parenthesis at the first, force it, right? Okay, so then if I open the parenthesis, I can do one of two things. If I have values in my, so if I have 6, I can either do another close, or sorry, another open, or a close. This takes me down to 5. If n is equal to 3, this is 2, and n equals 3. Right, and then this one, I can either do open, a close, or an open, or a close. So 4, and so on and so forth. So let's try it for a simpler n. Let's do n equals to 2. So we place a parenthesis, it was full of 4. So we place a parenthesis, we can either open it up, this is, now we have 3, 2, 1, we can either close it. Then we can open or close, open or close, and open, what's this? Close, so forth, open, close, open, close. So this gives us 1, 2, 3, 4, 8, right? Two times 2n. So then, it was 8. So then if we want to go back and evaluate, okay, now are these valid? Right, we can build these. Well, should we first try to maybe we should break it up. Maybe let's try to build every string combination at the start, and then build in some checking from there. That might be a better approach. Let's open up our MeCode practice file here. Oop. Okay, let's do 22.5. Okay, so let's say that n is equal to 2 here at the start. So let's say total is equal to this. We'll say combos. Right. So let's say, let's write a recursive function. So let's just say def whatever is going to be given in. Okay. If n is equal to 0, we're going to return. No, we're going to in a string. So if n is equal to 0, we're going to do combos.append the string, and then else if you have total, you'll reduce, and you're going to return from there. You're going to reduce total down by 1, and then do string plus equals to so I guess I'll say para, right? Para right here. So if I say, let me get my tunes back. Okay, so if I say that string plus equals to para, so I'm taking my, hold on, so if any, I add it to it. I'm gonna call helper on the new total. So this has to be, if it's greater than 0 else. So if it's total is equal to 0, we'll append and return. We'll reduce total. We'll increase the string, and then we will recall helper on the new string. If total. So we have to say, so we have total. We reduce it here. So what happens if we reduce it right off the start and say, okay, let's reduce total. If it equals to 0, we're going to append, else we're going to increase the string, call it on new total with the new string on both the open parenthesis and we're going to call helper and the close parenthesis. Now if I print combos, I don't know, I'm trying to just see if I can get all the combos made first. Uh-oh. This returns nothing back at the end of the call. If I call helper and then I call just print on combos here, does that do the trick? Helper on total, missing 2 arguments. Yeah, that's right. We gotta pass in a blank string here at the start, and then I need to do at the start is going to be a open parenthesis. Guess we're only getting 3 placed. Which I should be placing 4. So I'm not placing it on the 4th guy. Oh, so I have to go less than 0. Okay, so now we get the place. Okay, so now we get string combinations. These ones are the exact same. These ones are also the exact same. But these are also invalid. This is valid, valid. So you get 2 of every string combination, right? That's just how this works. So invalid, 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 valid, valid, valid. So we found 1, 2. No matter what you place that. Oh, I don't think I wrote this right because we shouldn't be getting 2 of the same each because total string parenthesis open string parenthesis close or sorry close. So at first I open this with total. Let's go through this. Bum, 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 bum. Bum, 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 bum. So we'll step into this function. Okay, our string is blank. Total is equal to 3. Because we're going to place a string here. Place the open string. We call that. Oh, because it's doing this. Oh. And then it's going and doing here. Trying to look at my call stack here. Okay. This is good, so that'll get added on to make it valid. It restarts. This got called. So then maybe I don't want to recursively call. Interesting. Hey Austin, how's it going, dude? Okay. We might have to come back to this one and try it again tomorrow. You might need to think about it for a little bit and do some studying on some algorithm concepts. I don't think maybe we just don't know the type it's looking for here. So we obviously get that we're going to use recursion here, and that I'm going to place a parenthesis along each recursive call stack. Now I can validate the check of that parenthesis by using a stack to house the open parentheses, and or a counter, right? Let's try something. Let's give one last attempt here before we move on. We call it for today. Try again tomorrow. So let's say that I am wanting to. Oh, I just lost my train of thought again. Okay, so let's say let me write it. I had that helper function to place the parenthesis, right? Let's just say if so I'm going to continually reduce down n until I get to no more values to be placed. And while doing that, keeping track of how many open parentheses have been placed so far. Okay. So if I say max opened is equal to n, right? You can't have more than n open and n closed. So if we know that, if max open is equal to n, then we can say how can we set this up recursively to place a value each time I say place, I was doing this before, like place para, right, which is like a helper function to actually place the parenthesis. String parenthesis. This will just add the parenthesis given to it and return back to you the string. We need to do this brain is starting to hurt. So if I use a loop rather, say for So we're going to go loop over and two and I don't know. Interesting. Keep thinking, Mike. Keep thinking. Don't give up. You got this. Keep thinking. This is good. It's hard now, but it'll be easier later. Pause. Just think about the future. It will be easier. Okay, so I'm trying to recursively call this function, place an open parenthesis. I just am struggling with how to actually set up the recursion itself, like whether to use like a helper function. Get messages. Bedtime reminder. It's a bedtime reminder. We shaved the beard, Mr. Astro. Okay. Let's keep thinking here. Okay, so I need to place a parenthesis. So I'm gonna walk through this. So what is my main function gonna do here? Generate parentheses. Do I have the recursion happen in here or in like a helper function? That's what I can't figure out. So if I say like if I think I do need a helper function, right? Given the open count and total arrows remaining. Okay, so the base case for this helper function is if the open count, right, ever exceeds n, we're going to return So if the open count ever exceeds n, then we know that we, okay. So I'm going to add the parent. In so many things, like remaining, say total. I have to also pass in the string. If open count is greater than n, we're going to return nothing. If total is less than 0, we're going to return string. My brain's starting to hurt. If total less than 0, we're going to return string. And then this is going to be given the para to place. So if para is equal to an open parentheses, an open parentheses, we're going to increase the open count by 1. If para, we're going to increase the open count if we hit 0. So I'm not going to do that there. If it's equal to this, if para equal to a closed parenthesis, we're going to open count stays. The open count would go down because we closed it. It would go down because we closed it, and then we would go ahead and open count would go down because we closed one of the open parentheses. But no matter what, we're going to do string plus equal the para given. And then we're going to do total minus equal 1. So if open count is greater than n, we're going to return saying that this is not valid, right? So I'll say false here. So if you get the string in the end, we'll say valid is equal to an empty array. Could I instead just valid dot append here the string given? So if total is 0, we're going to append the string and return true here. We found a valid string. Or no, we're all out. So if I call call helper on interesting. Capacity stack. So if the parenthesis I'm not returning anything. I'm returning anything. Hmm. 11 days. I might have to come back to this one, you guys. I'm burning out here. It's okay, I'm gonna think about this one. Let me do some research on some recursion stuff with leak code topics, so I can learn some more about this stuff. So you initially start with the left. You can either on the left or right. So I thought, and then you can click on. It's open, open, open. You already have max opens, so you can't open anymore. You have to close. What you do here, you have to close once more. Interesting, right? So we already knew that you always had to start with the open. So we always have to start with the open. String is going to equal to an open parenthesis, right? We're gonna say if n greater than one, or 0. N is greater than 0. We're going to create this string, right? And then we're going to think I'm done though for tonight. My brain hurts. Been building product at work this past 2 weeks, or this past week, and I built the product the fastest they've ever had me build it before. So I'm pretty burnt. Okay, so it's just annoying because let's say I have a stack. Stack's length can never become greater than 3. So let me write my helper function, right? I keep doing this, but I feel like we need some sort of helper function to do the recursion call, right? And we have to pass in a stack or some sort of counter to track the opens, right? Right? And so the base case is if the opened count ever becomes greater than n, right? This is invalid. So we're just going to do something. Okay? If we're going to add given some string, we're going to add onto it so let me just do this. Let me then say string here. Pass in the param. The pair to add. Then we're going to I'll just do this. Okay, so that'll add the string on, right? So this helper function will, if the open count is greater than n, then it's not going to do it. We're going to need to so this is that. So then if I say I need to do this 2n times, right? I need to loop 2n times. Set the place down. So if I say do this 2n times. I'm going to this will be add close, add open. Add close, add open. So I have the open count, the string, and the para. If the open count ever is greater than than n, we're going to return none in this case. Okay. If the whatever parameter is not given, is not in a open or closed parentheses, we raise a value error. If the para is in open parentheses, we increase the open count. Else, we need to decrease the open count by 1 and return the string, the new string. Okay, so if I say string starts off as this, we're going to loop over 2n times to build out a string. If I build out this string, I don't know. I don't think this is going to work. We'll find out. Concatenate string onto para, and then return string. Can I not return while I concatenate? I'm outputting null the whole time. Okay, so this is returning here. Okay. Okay, got you. So then we'll say we say valid is equal to an array, and I say if this is just going to add the single para onto it 6 times. Start with an open, you can you cannot place a close if you don't have an open, right? So if the para else here, the para is a closed parenthesis, if open count is equal to 0, return, else will reduce open count by 1. Open count 0, return, else will reduce open count by 1. Or equal to 0 will return, else will reduce it by 1 to add on this para that was closed, right? Okay, so then we say if add close build out 2 strings though. Nah. Hit dead end again. This is only going to build out 2 strings. We need the helper function to build the full string, and then we... Okay, so we need the helper function to build the full string. So the helper function has to build the full string. So if I say so what I'm going to do is I'm going to call return helper opened count string, and then we're gonna do it for this guy, and then for this guy, and then we're going not gonna then it'll return do I need to have a... So we'll have a base case here then also. If string, the length of string is equal to 2 times n, you're gonna return string. You're gonna return the string. So right off the jump though, I think if the paras given aren't in one of these two, then you raise the value. If the length of the string is equal to 2 times n, right? Then you have completed a string and you can return it. Now, if the open count is greater than n, this is an invalid. And then also if open count becomes less than 0. Okay. We're going to call helper on this guy here. Now we say if add close, we'll do valid append add close, and then if add open, okay. How's it going, Prism? I was having a few exams and busy. No worries, dude. I appreciate you. Hey, how's it going, shit? I appreciate you for actually. How's it going, Jumbo? Hey, Lexi, how's it going? What's going on, Jumbo? Appreciate you for coming in. Okay. What does this do? Anything? Maximum recursion zone. Okay, so what I'm doing here is I'm having a helper function that will recursively build valid strings down from starting with an open parenthesis, going through every option of either adding in another open parenthesis or a closed parenthesis. You can't add another open parenthesis if you exceed the open count limit, which is n, and you can't add a closed parenthesis if there is no already open parenthesis. Right? So then can I return valid here? I think I must get this recursion def though. Let's do this. Let's go church. Let's say. Let's talk. Say I am working on lead code 22 and am stuck. So I do not show me code or even give hints. I am just wanting some coaching regarding my current knowledge and attempt. I am learning on my own. I am giving it time. Here is my current approach. How does this look? Okay. So we're making an attempt at reasoning through this problem. That's awesome. You're tracking one of the equals cost of recursive backtracking calls with the custom approach, and it shows you're generally trying to think it through. Recursive thinking, right? You're on track with recursion. You're correctly tracking open count and building the string step by step. You're also differentiating between open and closed parentheses when recursing. You're recognizing the goal is to build strings of length of 2n, and you're trying to capture them once they reach that size. You're trying to ensure that the parentheses are balanced using conditions. That shows that you understand that this isn't just about length, but structure. These aren't criticisms, just points to focus on what does open count actually present. Are you tracking only open parentheses? If so, how do you track when to add a closed parenthesis? Would you benefit from separately tracking the number? Would you benefit from separately tracking the number of remaining closed and still use? You're calling it twice and setting both to add closed and add open. Makes the parentheses string valid, not just length based? When is it safe to add? You're in the hard part of learning version procedurally. Just all pacifying ourselves. Right, and reflect. Okay. So some of our notes here are: what makes a parenthesis string valid, not just length based? Well, a parenthesis string is valid if it has a closing parenthesis that follows an opening parenthesis, a corresponding opening parenthesis, right? So you can only place a closing parenthesis if you have unpaired opening parentheses. So I'll say our open count, say unpaired. Unpaired count, right? So our unpaired count and a string and the parenthesis to add. If the pair is not one of these two, we raise the value error. If the length of the string is equal to 2n and unpaired count is equal to 0, return the string. If unpaired count is greater than n, we return. If this, we open the count. If we add an unpaired, we increase that. Else, if open count is less than or equal to 0, we return. Meaning that we can't place Alright guys, I think I'm done for today. This is giving me a lot to think about here. Okay, so we want to build strings and unpaired count. If the unpaired count ever becomes greater than n, this is not a valid string. No, I don't play video games. These are my video games. So the thing is if I whiteboard. then if I... So you can only place... Okay, you can only place... Okay, if the para is equal to a open parenthesis, right? If unpaired count is greater than or is equal to n, this is not valid. And so you're going to return helper you've already maxed out on your unpaired count. Okay, so if our base case unpaired count. So if the para is equal unpaired count. So right now I'm going to say that m is equal to the length of the string currently. Okay. So I mean, do I have to keep passing in, like, more stuff? Unpaired count, the string itself, the pair to add, the open count, and the closed available, and the unpaired count, right? So if the parentheses that were given so if we are adding a parenthesis of an open parenthesis, if the unpaired count what if I do this? What if I said I don't pass in a parenthesis? I just say if I do pass in a parenthesis, if it's an open parenthesis, and if the unpaired count is equal to n, then I'm going to return helper of 0 or whatever the current open available the current unpaired count, the current string, and then I mean, we've been using a whiteboard this whole time, y'all. We've been trying to draw through stuff, so it's not like we haven't tried. Okay, well, I'm done. All right, 10:30 is my cut. See you guys. I'll see you tomorrow. I'll try this one again. I'm gonna do some research on some more patterns here. But anyways, I will be back in a second. Peace out, guys.